Hello, my name is Diatra Mitsash, and I currently work as a product lead at Johnson Labs. In today's talk, I will focus on clinical data abstraction and real-world data curation via active learning. Building large-scale structured datasets of detailed clinical information about patients and their journey is a critical tool in medical research or in clinical guideline development, in health policy development, or for medical decision support systems, for instance. Concretely, clinical data abstraction refers to the intelligent analysis and transformations that need to be applied to the heterogeneous clinical documents that together compose a patient record or a patient journey. The end purpose is to obtain their equivalent structured counterparts that are easier to analyze and to act upon. Clinical data abstraction is heavily used to study everything, from cancer to COVID, but is also highly challenging because of the massive and very specialized efforts which are required to abstract data from noisy and unstructured documents. Automating clinical data abstraction historically faced a couple of challenges. First, each project has different guidelines on what, how, and when data should be extracted and normalized. Second, the data is often taken from natural language documents or from a combination of structured, imaging, and document sources. And third, near perfect accuracy is required to enable medical decision-making. So models that achieve 90% accuracy, for instance, are just not good enough. The usual flow that we have seen in abstraction projects include the following 6 steps. First comes the OCR, which helps extract relevant information from images or from scanned documents or PDF documents and obtain the corresponding text information. Now, often documents contain sensitive health information or patient information, and de-identification needs to be applied in order to be able to share the documents with third parties or to analyze them at larger scale or in an integrated or shared context. Processing large heterogeneous amounts of documents, we often need to first identify what the document is about in order to be able to send it to the right analysis pipeline. This is normally done by classification. For instance, here, a classification model will deduce that the provided document is a radiology report and will send it to the radiology pipeline. So once we have the identified and classified text, we can then extract named entities using NER models. For the radiology examples that we have chosen, we'll apply a specialized taxonomy as the one above, which contains labels such as body parts or medical devices, measurements, test results, imaging techniques, and so on. So this is the first step in extracting structured data out of natural language text content. Okay, the next step is assertion status. It is often the case that we want to go even further, and once we have the relevant entities mentioned in the text, for instance, symptoms, extracted, we also need to check if they are present or absent or uncertain, or if they refer to someone else, such as, for instance, someone in the patient's family. Finally, it is also possible to resolve the identified named entities with respect to standard taxonomies, such as ICD-10, SNOMED, or RxNorm, among others. And this is useful for disambiguation or for reimbursement purposes. So on top of the entities that we have identified, we will also add the SNOMED codes, which correspond to them, and then the SNOMED descriptions. Out of the 6 steps of this workflow, my talk today will focus on classification, name entity recognition, and assertion status. All of those 3 tasks currently supported out of the box by the Annotation Lab. The Annotation Lab is a highly productive data labeling tool which was designed and implemented by Johnson Labs to support different types of annotations and review projects. The first advantage when using the Annotation Lab is that you never have to start from scratch, but you can jumpstart your project with pre-annotations. Due to the tight integration with Spark NLP and Spark NLP for Healthcare, the tool can predict over 100 clinical and biomedical entities which are already learned by different Spark NLP for healthcare models and pipelines. So this allows your team to reuse hundreds of predefined models and to considerably reduce the manual annotation effort. So the tool is built for high compliance industries, and it is highly secured and offers complete audit trail for all users' actions. The Annotation Lab is very focused on increasing the productivity of your team of clinical annotators. It offers features such as optimized screens and keyboard shortcuts, and also automated task transitions. It also offers support for writing and for sharing annotation guidelines, for putting together custom workflows involving annotators, reviewers, and team managers. It also includes tasks and user analytics, which allows the team manager to keep up with the productivity and with the overall status of the project. Finally, the most important feature that we have added to the Annotation Lab is the Auto NLP. When using the Annotation Lab, a team of domain experts, such as clinicians, can run an abstraction project on their own without any help from a data scientist. Normally, the steps to follow are the 5 identified in this picture. First, you create a new project and put together a team of clinical annotators or any other type of domain experts according to your vertical. You then import the first batch of documents and ask the annotators to prepare some training data. Then you can train a model that will learn based on the examples provided by the humans. The Annotation Lab will do the training and deploy the model behind the scene. Then you can use the new model to predict labels on a batch of new and unseen documents. This way, your team will just need to check the predictions which are generated automatically by the model and maybe correct them if that's necessary, instead of annotating from scratch. Finally, you have the option to use the active learning feature. In this case, the Annotation Lab will continue to learn based on the actions of your clinical annotators, and it will continue to improve the model in the backend. This will happen behind the scene, and it will not even be visible to your annotators. When a new version of the model is available, it will be deployed, and it can be used to pre-annotate new documents. Now let's see how all of that can be done in practice. My demo today will focus on document classification and name entity recognition just because of the lack of time. Assertion status detection is supported out of the box by the Annotation Lab as well. Let me start by connecting to the Annotation Lab. Now I get redirected to the project page. As you can see, I currently don't have any projects and no projects are shared with me. I'm going to go ahead and create a new project for which I will define a name, a project description, and some instructions for the annotators so they will know the criteria for assigning one class or another to the documents. For this classification project, I want each task to be classified with respect to one of the 5 classes: neurology, orthopedy, radiology, urology, or other. Once I finish these 3 steps, I click on the Create button and my project will be saved to the Annotation Lab database. Next, I will create a team of clinical annotators that will work on this project. For this, I move to Manage Project Team tab, and here I select the available annotators I want to add to my team, and I assign a role to each one of them. An annotator is able to see the tasks which have been assigned to him or her and can create annotations on the documents. For the classification projects, the annotator's task is to assign one of the 5 classes to each one of the documents. The reviewer is able to see the work of the annotators and approve it or reject it in case he finds issues that need to be solved. The manager is able to see the work of the annotators and of the reviewers and can assign tasks to team members. This is useful for eliminating work overlap and for a better management of the workload. Once I have a team in place, I start configuring the project. For this project, I choose the text classification template. The default configuration for text classification is now added into my config section. You can see this is a configuration for sentiment analysis with 3 possible classes: positive, negative, and neutral. I will edit this XML configuration to add my 5 classes and customize the name of the choices element I use. I will now do some quick UI updates to improve the usability of my interface. On the right side of the screen, I see a preview of the user interface with the 5 checkboxes corresponding to my choices. Once I finish, I click on the Save button. I am now redirected to the import page. Here, I can start adding documents to the project. Different input formats are currently available, the most popular being JSON. I can also add multiple JSON files at a time by selecting them all or by archiving them in a zip file. For the beginning, I'm importing only 2 tasks, so I show you how the manual annotation work is done. Once the import is successful, I am redirected to the tasks screen where I see the list of all available tasks. I have 2 tasks now corresponding to the 2 documents I imported. Each task has a task ID and a task name. Under each task, I see some metadata about it, the time of the import, the creator, and the annotators and reviewers assigned to the task. Each task has a status as follows: incomplete when no one has started working on this task, in progress when at least one annotator started working on the task, submitted when all the annotators which are assigned to the tasks have submitted a completion, and reviewed in the case there is a reviewer assigned to the task. If the reviewer has reviewed the task, then it gets the status reviewed. Currently, both my tasks are incomplete. So I click on the name of one of the tasks and I'm redirected to the labeling screen. Here, in the upper side of the screen, I can see the 5 classes that I have defined for the project, while in the center of the screen I see the actual content of my document. On the right side, I see the current status of my work. I see there is one completion which is in progress, the completion created by default when the user accesses the labeling screen. I see there is no prediction, which was created by a predefined or by a newly trained model, and there is no other type of results. Now, as an annotator, I start reading the document and use my experience to assign the document to one of the target classes. I can do this by simply clicking on the corresponding checkbox. When I finish, I save my work and then I submit it. When a completion is submitted, it is no longer editable and it cannot be deleted. This feature ensures a complete audit trail of all the completions created by all the users. When I finish working on this task, I click Skip, and the next document in line or the next task, which is not completed, will be served automatically. This is a big help because I don't have to navigate back to the task view, search for an incomplete task, and start working on it. Instead, this task serving is done automatically by the tool. Again, I read through the document and I conclude this task must be tagged as other. I save it and submit it. If I click Skip again, I will get this message that no more data is available for labeling because all of the tasks are now submitted. This means I already have some examples or training data a model can learn from. So now, let's speed up a little bit and go to the import screen and import some more tasks already annotated and submitted by someone in my clinical annotation team. Once the tasks are imported, we can explore them via the available filters and search functionalities. I also often use the duplicates identification features in order to eliminate redundant documents which can bring contradictions or inconsistencies in the learning data. Now let's assume that the initial annotation work is done. I'm going back to the setup page, and here I navigate to the tab below the project configuration called Model Training. In the Model Training tab, I have a way to fine-tune the training parameters, such as the number of epochs to use, the learning rate, or the train test split. Once I define the params of my experiment, I can save them. Then I click on the Train Now button. At this point, the Annotation Lab will start training a new model using the data that was manually annotated or added into the project. Once the model will be ready, it will be automatically deployed and I can use it for pre-annotations and predictions either in the current project or in another project as well. The current status of the training can be seen here on the Model Training tab. I can see that the training is at step 1 out of 3. The same information is available in the Tasks view. Here I can see that the pre-annotation button is no longer active because something is going on in the backend. A new model is being trained and deployed. Once the training is done and the model is deployed, this button will become active again. Now going back to the Model Training tab, I see a second option here, Active Learning. Initially, the active learning is inactive. It can be manually activated and it will be turned on by the Annotation Lab tool after the first manual model training. If activated, a new model will be trained every 50, 100 or 200 completions. This will happen behind the scenes in the backend. The annotators don't even have to be aware of this, and once the new model is available, it will be automatically deployed and can be used to pre-annotate unseen tasks. Let's fast forward 5 minutes until the training is done. I now see a message saying that the model was successfully trained. Please notice that the model which was just trained has been added to the header tag defined for the current choices. That means that all of the classes that I have defined under this header will now be predicted using this model. This configuration update was done automatically. When I'll train the next version of the model, it will be updated also automatically. Now if I go to the import screen, I want to import a new set of documents for testing purposes to see how this model works. I will filter my view to see the new tasks by activating the incomplete filter. I select them all and click on the Pre-Annotate button. This activates a pop-up with basic information about the model, which is currently deployed, and allows me to either pre-annotate using the model or deploy the model for the current project. In this case, because this is the only project on my Annotation Lab instance, I go with pre-annotate. I can get the status of the current pre-annotation by clicking on the drop-down, and I will see how many tasks are failed or successful or the ones that are still running. As you can see, for my new documents, I have predictions which are automatically created by my new model. If we check this first example of document, we can see that it has been correctly classified as being related to orthopedy. And let's check another example now. In this second case also, we can observe that the document has been classified as being a radiology report. Okay, so now let's go ahead and check the next step of the data abstraction pipeline, which will be the creation of an NER project. I will define a name and a short description for this new project and click on the Create button. Then I choose the name Entity Recognition template, and this will add some generic labels to my project configuration. I now navigate to the Spark NLP tab, where I can see some of the available pre-trained models. I will choose some generic clinical labels, which are included in NER Clinical Large Model. I add those to my configuration and proceed by removing the generic labels which I don't need. I can now add additional custom labels which are specific to radiology reports, such as imaging findings, procedures, medical devices, tests, and so on. I save my configuration and import some pre-annotated tasks. Alternatively, I can ask my team of annotators to prepare some annotations for me. Let's check now how an annotated document looks like. In the upper side of the screen, I see the labels added to the taxonomy with different colors assigned to them. In the document area, I see the text with the annotations. For adding such annotations, the user simply selects the label and then selects the text chunks. A submitted completion can no longer be edited, as in the case of the classification tasks. However, if you find some errors and you want to correct a submitted completion, or when, for instance, the annotation guidelines change and updates need to be implemented, you can copy the current completion to a new completion, which is now editable. For instance, in this example, chest is not an imaging test, but a body part, so I'm going to remove the current annotation and add another one, a correct one. Please notice that you can define multiple annotations for the same text chunk, such as here. The chest token is annotated with body part, but is also part of a larger annotation, medical device. Once you finish your edits, you can save and submit your completion, and you can store it as being ground truth. This way, it will be used for model training. Once I have enough training data, I go on and train a new model. Let's fast forward a little bit until the model training is ready. The model training has finished, and let's check the updates made to the project configuration. I see here that model information has been added to each one of the custom labels I defined. Checking now the Spark NLP pipeline configuration tab, we see that the new model, which has been just trained, was added to this list of existing models. Now let's go ahead and import some test data to see how these models perform. I import only one task, I filter by incomplete. I now select the new task and run predictions on it. When pre-annotation is done, I go to the labeling screen and I see here all the predictions which were automatically added to the model. I see body parts have been identified, different findings, directions, measurements, medical devices were added to my document. The predictions, as you know, are not editable, so I create a new completion and I go ahead as annotator and check all the annotations created automatically and if necessary correct them. This is a very simple process. Now let's imagine I need to create a new project. I now scroll down to my Spark NLP config tab where I see the models which have been previously created. I can reuse those models in my new project if necessary, and I can combine them with other available models. Let me import some test documents now and show you that a new project can be built on top of already learned labels, which will significantly decrease the load of the clinical annotators and will highly increase their performance. In our experience, the use of pre-annotations reduces the annotation time with up to 70% and produces a great performance boost. With this, I wrap up my demo. Thank you very much for your attention. If you have any questions, please send me an email or contact me via LinkedIn.